So please unmute yourself.
So good morning to all of you. Let us start quickly what we did in earlier classroom. We quickly summarize what we have done up till now. So we already seen what is cardinality of set, what is subset, what is proper subset, what is superset, what is proper superset, then what is equal set. Then we have seen what is power set. After that, we also have seen one of the operations that we can perform on the set, that is Cartesian product, which can be performed on, it is a binary operator which can be performed on two sets. So the result is ordered pair. Then we have seen another operation, that is union of two sets. Then we have seen another operation, that is intersection of two sets. Another operation that we have seen, that is complement of set. This is called as absolute complement. What is meaning of absolute complement? If it is just mentioned complement of set A, it is by default with respect to universal set. Okay. So today we are going to learn another complement of a set, that is called as relative complement of a set, or it is also called as set difference. Now, what is meaning of this? It is in line with what we have discussed in earlier classroom. Let me just open. In earlier classroom, we have seen that whenever we want to take a complement of a set, we need to, what is meaning of complement of set? That we will eliminate all the elements belonging to that set from the universal set, and whatever are the remaining elements from this universal set after excluding the elements of this set, that will become a complement of set A. Okay. So, therefore, what exactly we need to do in this case, it is called as absolute complement. So set difference is what? For example, let us say set B is equal to, let us assume some elements. Of course, whatever we are taking now context set for, in context to that we want to take a complement, that set need to be also subset of universal set. So let us say set B is, let us say this. Okay, let me take another set. Set C is, let us say, okay. So when I want to take complement of A with respect to B, so what is set difference? Let us try to understand set difference A minus B. What is meaning of A minus B? So A minus B is nothing but excluding the elements of B. What is remaining in A is called as set difference or relative difference. Excluding the elements of B from set A, whatever are the remaining element is called as set difference or relative difference of A with respect to B. So in line with this, if I want to find out B minus A, that is equal to excluding the elements of A from B, whatever are the remaining, that is set difference. So can you tell me what are the elements B minus A?
9 and 10.
Yeah. So we will eliminate elements of A from set B. So remaining elements are 9, 10. So let us take A minus B and tell me now what is the set difference.
5, 6.
5, 6.
5, 6.
Okay, excluding the elements of set B from set A, whatever are the remaining elements in set A. So from set B, 1 and 2, it is removed. The rest is same, so only 5, 6. That's it. Now, if I do this, what is the answer? Yeah, I am waiting for the answer.
Null set.
Yes. Now, yeah, come on, quick. It should be very fast.
Sir,
What is the answer?
it will be equal to A complement.
Yeah, so what are the elements?
3, 4, 7, 8, 9, 10.
What are the elements?
3, 4, 7, 8, 9, 10.
Okay. So now you can understand what is meaning of, huh? Correct. So what is this? This is basically absolute complement as well as this is relative complement. So relative complement, when it is taken with respect to universal set, then it is become absolute complement. Otherwise, if relative complement is taken with any other sets which are subset of universal set, that is called as relative complement, or it is also called as set difference. So for example, A minus B. So basically this is set difference, or you can also call it as relative complement with respect to set B. So relative complement of set A with respect to set B, where set B and set A both are subsets of universal set. So is it clear? Yes or no? Please immediately respond in chat box. If any questions, please let me know. Quickly give feedback in chat box, yes or no. Okay, let's proceed ahead. Yeah. So what is set difference? Set difference A minus B, it is collection of all the element X such that set difference A minus B, it is collection of all the elements X such that X belongs to A and X do not belongs to B. This is the standard definition of set difference. A minus B, this is set difference. This is also equivalent to, see, A minus B means what? Excluding the elements of B from set A. So this is also equivalent to excluding the elements of B from set A. That means what? We are taking, we are eliminating which elements exactly? The complement or intersection part. Okay. So basically what we are doing, we are taking A intersection B complement. So B complement is everything. That is your universal set. And then we are doing A set intersection with this remaining element, whatever are part of this set A, that will become your A minus B. This is alternate way you can find out the set difference. A minus B is also equivalent to A intersection B complement. So what is this B complement? This is absolute complement with respect to the universal set. Let's proceed ahead. Symmetric difference. So what is symmetric difference now? Symmetric difference is shown like this symbol. Please note down in your notebook. Later on, you should be able to refer back. So what is symmetrical difference? Asymmetrical difference B, it is collection of all the elements X such that X belongs to A and X do not belongs to B, or X belongs to B and X do not belongs to A. So basically it is union of A minus B and B minus A. So it looks like something like this. Let me just check with the ideal hand. Yeah, it looks something like this. Symmetric difference means what? You are just going to eliminate the common elements from both sets, and whatever are the remaining elements in set A and set B united together is called as symmetric difference A, symmetric difference B. So with respect to the definition, it is collection of all the elements X belongs to A and not belongs to B. It is all the elements, this is or X belongs to B and X do not belongs to set A. So it is like this. Is it clear? Yes or no? Please let me know. In chat box, quickly respond.
Sir, means
Okay.
we remove the
So,
intersection part,
yeah.
no? Means
Yeah, it is basically union of A minus B and B minus A. So let us do it quickly with respect to this. So find out by yourself A symmetric difference B. Find out. So what is that answer? Find out. All the students kindly do it quickly and post your answer in the chat box. Similarly, B symmetric difference C. Find out quickly in the chat box. Respond me. Similarly, U symmetric difference A. Find out quickly. Let me know what is your answer. Whatever answer you are posting, I should know your answer. You are posting answer for what? Sarah Khan, your answer is 5, 6, 9, 10. This is for what? Unmute yourself.
sir, for asymmetric difference B.
Okay, I will just note down here, and remaining student just confirm whether you are getting same or not. Whatever she is writing, I will just reflect here 5, 6, 9, 10. This is the answer given by Sarah. Remaining students just confirm whether it is right or wrong. So similarly, now go ahead with B symmetric difference C. Yes, Sarah, tell me.
Yes, sir.
B symmetric difference C.
Yes, sir, I'm doing that.
Okay.
Sir, 3, 4, 5, 10.
3, 4, 5, 10. Okay. And next, U symmetric difference A. What is U symmetric difference A?
Sir, it will be U on, it will be equal to the universal set only.
What is the definition of symmetric difference? A symmetric difference B. It is collection of all the element X such that X belongs to A and X do not belongs to B, or X belongs to B and X do not belongs to A. Or it is also equivalent to A minus B union B minus A. So come on now, tell me what is the answer.
So it will be 3, 4, 7, 8, 9, 10.
Sir, in this, the null set will also be added.
Okay, just a minute. Let me come here and let me just type. This is equal to what? U minus A union A minus U. Yeah. So now tell me what is U minus A. U minus A is this. So what is A minus U? We already found U minus A. So what is A minus U? Come on, tell me quickly.
Null set.
Null.
Null set.
Null
Okay.
set.
And now what we want, use symmetric difference A. That is what? U minus A union A minus U. So what will be the answer?
It will be 3, 4, 7, 8, 9, 10 and null set.
A minus U is null. Okay. If any set union with null set, what is the result? Set A union null
Sir,
set.
it
What
will
is the
be
result?
only 3, 4, 7, 8, 9, 10.
Okay, it will be
Yeah,
only
that is what
that
I'm
much.
saying. It is same set. Correct. So I'm sure now everyone is aware what is happening. That's it. Done. Let's go ahead. This is the proof that how you can prove this is equivalent to this. So if you want to prove how A symmetric difference B is equal to A minus B union B minus A, basically what is A symmetric difference B? It is, by definition, what it is, set of all the element X such that X belongs to A and X do not belongs to B, or X belongs to B and X do not belongs to A. So what we can do with respect to this, we can understand that it is X belongs to A minus B. When we say X belongs to A and X do not belongs to B, that means X belongs to A minus B, or X belongs to B and X do not belongs to A, that means X belongs to B minus A. So it is basically X belongs to A minus B union B minus A. This is the way you can prove that left hand side is equivalent to right hand side. You can go reverse also by starting with right hand side, and then you can prove this is symmetric difference. That's it. Now let us try to understand the important laws of set theory. Identity law. So what is identity law? When you do intersection, any set A intersection with universal set, you will get the same set. Set A union with null set, you will get the same set. This is called as identity law. All these are the laws belonging to the set theory. So set A intersection with universal set is always same set. Set A union with null set is always the same set. So this is identity law. Whatever the set is here, it is same. Okay, domination law is what? Here, what is meaning of dominating means if you are doing union with universal set is always dominating. If you are doing intersection with null set, you are always getting set A. So it is domination law. Please have a note of same in your notebook quickly. Now the next is idempotent law. What is meaning of idempotent? If we do union and intersection with the same set itself, we are getting the same set. A union A is also A. A intersection A is also A. And identity law and domination law is with respect to universal set and null set. So in identity law, we are doing A intersection. See, basically, what is the difference? In identity law, how we get same set by performing what operation with universal set and null set, that we are mentioning here. If we perform intersection operation with universal set, we are getting A set. If we perform union operation with the null set, we get the same set. So therefore, it is identity law. Now here, we are just doing the reverse. That is A union U. What exactly we are getting? That is universal set. We are doing A intersection null set. We are getting A. So this is domination law. Exactly opposite of identity law. Okay.
So,
Idempotent
but
law.
in intersection we take the common elements, no?
Pardon?
In intersection we take the elements which are common in both the sets. So how A intersection null set becomes A?
Just a minute. What you are saying? In domination law, you are saying.
Domination, the second one. In intersection we take.
Yeah. This is typo
It
error.
should be null.
Wait. This is not my slide. This is slide from the book. This is absolutely right. I appreciate. Let me just use the pen. This should be. This is absolutely wrong. This should be null set. Yes, you are right. Okay. This is typo error. Eliminate this. This should be null set. So good, you are keen observer. So is there any ambiguity in these three laws? Any questions? Is it clear? Please respond quickly, yes or no. Are these laws are clear or not? Respond quickly in chat box, yes or no. Yeah, let's go ahead. There are other laws. Complement laws. This is what exactly we have already learned. What is A union, A complement? It is always universal set. And what is A intersection, A complement? It is always null set. So this is complement laws. Double complement means what? If we take complement of complement, then we will get the same set itself. Now, the next laws are talking with respect to the operator having more than one set. So, commutative means we are checking the property of this operator. Whether commutativity means what? It is like 5 plus 3, you are getting 8 in a mathematical operator plus 5 plus 3 is 8. Similarly, if we perform 3 plus 5, if we change the position of the operands, whether you do 5 plus 3 or whether you do 3 plus 5, if you are getting the same result for all the operands with irrespective of the position, then we say the operator obeys commutativity law, commutativity property. Operator is obeying commutativity property. So A union B is always equal to B union A. Similarly, A intersection B is also equal to B intersection A. So both union and intersection operator obeys commutativity property. Now, what is meaning of associativity property? It is with respect to the three operands. If we are having three operands, like I want to add 5, 3 and 10. So whether I do 5 plus 3 first and then whatever the result I will get, in that I will add 10, or whether I will do first 3 plus 10 addition and then I will do 5 plus the result. If both results are same, whichever way I am doing the first addition, then we say that operator obeys associativity property. So basically, here we are having, irrespective of this parenthesis, we just want to perform A union B union C. So we are having two choices. Either we perform A union B first or you perform B union C first. So if now in this case, A union B is performed first, whatever the result you are having, then you are performing union B C. So if this is equivalent to this, that you perform B union C first and then A union that result, if this is equal, then we say the operator is obeying associativity property. So in set theory, union operator as well as intersection operator obeys associativity property. This is with respect to three different sets. Okay. Now, what is distributivity property? Distribution law is with respect to three sets into picture, and you do have one operator inside and different operator outside. So right now we are talking about whether union operator is obeying distributivity property or not. So what does it mean? In layman's language, you do have something like in mathematics, you are having 5 into 3 plus 5, 3 plus 10, whatever. So you can have alternatively, this is equal to, you can have 5 into 5 into 3 plus 5 into 10. This you already learned in your mathematics, what is distributivity property. So same thing is here, when you just apply this operator, so what will be the result? First you will do A union B intersection A union C. Inner operator will become outer operator will become inner operator. Okay. Similarly, with respect to intersection also, A intersection in bracket B union C, this is equivalent to A intersection B union A intersection C. Is it clear? Yes or no? Please let me know in quickly chat box. Is this clear or not? Okay, let's proceed ahead quick. Now, what is De Morgan's law? So, what is De Morgan's law? De Morgan's law is we want to check what is the effect of complement operation on union and what is the effect of complement operation. Whenever I am talking complement, it is universal set in picture. So, it is absolute complement. So, if we want to check what is the result of this absolute complement effect on the union operation, absolute complement effect on the intersection operation. So, De Morgan's law 1, it holds like this. Whenever it is like this, so complement of A, whatever the operator is here, if it is union, it will become intersection. If it is intersection, it will become union, and then complement of P. So, you are just separating it in two. Is it clear? Yes or no? Please let me know quickly. Any questions up till now? Okay. So let's proceed ahead. If you want to prove with respect to this left hand side is equal to right hand side or not. So basically, whenever you want to prove that this is equal to this, so you know very well see basically this is the resultant set. If you perform the operation, you will get some resultant set. If you perform the operation on this, you will get certain resultant set. So you may call it this is X and this is Y set. Okay. So when we say X is equal to Y, can anybody tell me when we say X is equal to Y? What is interpretation of this? When we say set X is equal to set Y, what does it mean?
A is subset of B and Y is subset of X.
Pardon?
X is subset of Y and Y is subset of X, then X equal to Y.
Correct, absolutely right. So what exactly? Whenever we want to prove this, it means we need to prove that if it is subset, see, whenever we want to prove that if it is subset, X is subset of Y. See, when we say X is subset of Y and we just derive this, we are getting something. And when we say Y is subset of X, in that case, if we derive and if we are getting also same thing, so from 1 and 2, we are landing into the same interpretation, and then we can say X is equal to Y. So we'll see now in this example, when we say this is subset of A intersection, this is subset of X is subset of, we are starting with this now. See, what is X is subset of A union B? What does it mean? When we say set is subset of itself, in that direction we are starting now. So X is subset of X. So what does it mean? X is belonging to set A union B complement. It implies X do not belong to A union B. When it belongs to A union B complement, it means X do not belongs to A union B. It means X do not belongs to A and X do not belongs to B. So it means X do not belongs to A means what? X belongs to A complement. X do not belongs to B means what? X belongs to B complement. And this is AND. So therefore it is intersection. So we landed to this part. X belongs to A intersection B. Sorry, X belongs to A intersection A complement intersection B complement. Okay, this is from the subset side. Okay, so we will start now with respect to this Y side. So from this, we what is the conclusion? That we identified that this set is subset of this set. We started with itself and we landed that this set is subset of this set. So similarly, we will start with this. This set is subset of itself. So X is belonging to this entire thing, A complement intersection B complement. What does it mean? X do not belongs to A and X do not belongs to B. So what does it mean? X do not belongs to A union B. So what does it mean? X belongs to A union B complement. So from this, what we came to know, Y is subset of X. And from this, what we came to know, X is subset of Y. And therefore, from 1 and 2, we claim X is equal to Y. This is the way you can prove any kind of equalities between two sets. There is another way to prove this, whether this is equal or not, by using the membership table. So what is meaning of membership table? Whatever this set is involving some sets, so set A, B, A, B. So if we take some truth table values, membership table, X, so X is not in the specified set is denoted by 0, and X is belonging to set is denoted by 1. So let us assume X belongs to set A is denoted by 1, and set X do not belongs to set A is denoted by 0. So what are the possible combinations? So we are having two sets. So there are, X is in general we are talking, no matter what is that X element, in general we are talking X element. So we are having two sets into the picture, so four possible combinations. So X is belonging to A as well as X is belonging to B. X is belonging to A, but X is not belonging to B. X is not belonging to A, X is belonging to B. X is not belonging to A, and X is not belonging to B. So if you take the complement of this set A, and if you take, this is not exactly the complement of set A, this is exactly, if you do have X element in general into your picture, this is the membership belonging to set A. We already discussed this is a crisp set. Either element belongs to the set, the membership value is 1. If it do not belongs to set, the membership value is 0. So if we take the membership values complement of that set, so if it is belonging to 1, then it is not belonging to. Belonging, not belonging, not belonging, belonging, not belonging, belonging. That way, same way, like this. So whatever the in your left hand side, you do have A union B. So for A union B, what exactly you are doing? 1 into 1, that is 1. 1 into G. It is not exactly the mathematical operation multiplication. A union B means what? Either it is belonging to A or it is belonging to B. That means either it is belonging to A or it is belonging. So, and it is belonging to both. Somewhere it should be belonging, either A or B. If any set contains that X element, then it is belonging to A union B also. So it is belonging to A, it is belonging to B. Somewhere it is belonging, therefore it is belonging to union also. Belonging to A, not belonging to 0, but somewhere it is belonging in union. One of the set it is belonging, therefore A union B is also 1. A union B is also 1. Nowhere it is belonging, it is 0. And you take the complement of this, you get this. And you take the intersection of this, you get this. So by looking to this column and by looking to this column, you can easily prove a left hand side is equivalent to right hand side. This is another way you can prove the equality. Either you can prove with the help of this derivation, or you can prove with the help of membership table. So is it clear or not? Let me know in the chat box quickly. Any questions? If it is clear, mention yes. If any questions, please let me know. I'm waiting for the response from all the students. Please respond quickly. All right. If there are no questions, let us proceed ahead. Yeah. This is general connection via Boolean algebra. This, whatever we are talking right now, this part is called as Boolean algebra, union and intersection, Boolean algebra. We'll see this later. So, proof using logical equivalent set definition. Logical equivalent set definition means what? A union B complement is equivalent to A intersection. A complement intersection B complement. So A union B complement of that, this is equivalent to, this is equal to, it is collection of all the element X such that X belongs to A or X belongs to B. This is meaning of this. X belongs to A or X belongs to B. And if you take the not of that why not we have taken? Because of this complement. Okay. This is equivalent to what? Not basically we have not yet started with the logic. In logic there are certain operators like negation and or single implication, double implication. So when we will touch that part, we will be able to understand all these symbols. This negation operator is nothing but the complement. Okay. So negation of x belongs to A or x belongs to B. So basically, if we apply this negation, De Morgan's law, reverse way, so what you will get, negation of x belongs to A, this will become and negation of x belongs to B. Negation of x belongs to A means what? X belongs to A complement. Negation of x belongs to B means what? X belongs to B complement, and operator will remain as it is. So x belongs to A bar. In shortcut also it is called as A bar in logic, or sometimes in set theory it is called as complement. So x belongs to complement of A and x belongs to complement of B, and this is equivalent to, then we say it is set A complement intersection set B complement. So basically this is using logical equivalent set definition. We'll skip this for time being. Yeah. So the summarization, what we completed in today's session, we completed all the set identities. Identity means all the laws of the set theory. Let us quickly recap what are those laws. Identity law. What is identity law? Identity law means what operation we can perform with union and null set, so that union set and null set, so that we will get the same set. So with respect to the null set, we perform union. With respect to union set, we perform intersection. We will get the same. Domination laws is nothing but what operation we can perform with universal set and null set, so that we will get the same set itself, that is universal set and null set. So we can perform A union universal set, we will get same. A intersection null set, we will get the null set. Idempotent law, if we perform operation with itself, same set, we will get the same set. Double complement law or complementation law is complement of same set is same set. Commutative law, union and intersection obeys the commutative law. A union B is equivalent to B union A. A intersection B is equal to B intersection A. Associative law is with respect to three sets and two operators. So three sets and the same operator. A union B union C is whether you perform this and then A union that, or you perform this and then union C, both are same. This is associative law. Distributive law, it is three sets and two different operators. So A intersection B union C is equivalent to A intersection B union A intersection C. So if you open up this, inner operator will become outer operator will become inner operator. That's it. De Morgan's law, complement of union is equivalent to individual sets complement and then intersection. Absorption law, basically this we have skipped, this we have not yet discussed, this we will discuss in next classroom. Complement laws, A union A bar is U and A intersection A bar is null set. So have a copy of this, maybe you can take a snapshot and keep this copy with you for the next class. So with this, we'll stop here. Please post your attendance in the chat box, roll number followed by your name, and then you can log. Thank you.